Okay, let's go. Good afternoon, I'm Leila Rebou from NRB, and I'm Head of Data Science and Artificial Intelligence Solution at NRB. And today I'm going to explain you a case and how to boost a computer vision application. First, I'm going to introduce NRB Group, which is a large IT service provider in Wallonia. And NRB is constituted by NRB itself, but also by different subsidiaries grouped into different pillars. For example, you can see Zorgi, a company specialized in healthcare, or Sivadis, a company specialized in IT for local municipalities and smart cities. In this way, NRB covers all sectors in Belgium. Some key figures for NRB. NRB represents more than 3,000 of collaborators, and revenue will reach 500 millions of euros in 2021. Oh, no, sorry, the forecast is for 2020. So we will have 500 millions of revenues in 2020. In particular, at NRB, we have different departments specialized in different IT activities like mainframe, cybersecurity, but also digital transformation and innovation. And my IT team is included in this department. Our data scientist team is supported by lots of different profiles like architect, developer, or business consultant, and so on, so that we are able to deliver an end-to-end project in artificial intelligence. An artificial intelligence project is cut in different processes. The first step is business consultancy via different type of workshop to co-create an artificial intelligence solution. After this step, we start by a small project called POC, or Proof of Concept. It's a small project of implementation to validate the benefits of artificial intelligence. If it's positive, we can start a real project of industrialization in IT. It's a traditional project in IT. We have already delivered different proof of concept. For example, we automatize benchmarking of historical and updated terms and conditions in insurance sector. The objective of this artificial intelligence is cost reduction. 30 to 40% of time saving can be reached thanks to this artificial intelligence. We studied also a second case in operational efficiency in a factory of floor covering material. We demonstrated a reduction of 30 to 35% of re-rendering. And if we analyze data with machine learning techniques, and so we can prevent the appearance of defects once causal factors are identified. Now, let's talk about a project in which artificial intelligence is industrialized. I'm going to discuss this computer vision case called Triscan. It's a computer vision case for citizens, but it could be easily transposable into industry, in particular in recycling chains. Our client, Idelux, which is an intermunicipal cooperation active in waste management in Luxembourg, has wanted to launch an application for citizens to help them in their sorting. Basically, it's an application in which citizens can detect and identify the waste, and this application returns a sorting instruction. It's a real computer vision project. The first thing to do is, of course, collect lots of data, lots of waste images. As the Walloon milk bottle has some particularities that the Chinese one has not, it seemed difficult to use public database available on the net. So to take account of these very local specificities in the shape or in the branding, there is no miracle, unfortunately. You need to take a bottom-up approach and collect by yourself your own photos in the recycling park. That's what we do at Saint-Vite. Another approach is to use the network effect to get photos by audience via social media or emailing. But with this type of crowdsourcing, it's limited in 2021 when everybody is saturated by news on social media and when there is no incentive or gamification. Once all data collected, you need to clean them, to format them, to labelize them. Some companies are specialized in this kind of pre-processing step, like Figure 8 or Amazon Mechanical Turk. Generally, it's a manual job, very badly paid. Contrary to lots of artificial intelligence companies, we decide to valorize this exhausting and repetitive job by doing by ourselves. So we use our own labelization platform and we labelize more than 10,000 images. It's a very, very huge work. Now, it's time to design the application itself. The application is based on an Amazon architecture in which all artificial intelligence models are deployed into microservices via the famous AWS Lambda function. We decide to use an open source model called YOLO. You only look once. It's the abbreviation of YOLO. It's a proven and renowned model. Let's do it and let's go. Let's see. Look. See the first results. Sometimes it works. Sometimes it doesn't work. Here it doesn't work. Here it works. So how to boost it? This IE is not performant. For that, come back to the basics of data science and let's use a standard methodology to improve the artificial intelligence performance. How to do? First, we applied a basic model, ResNet. It will be our baseline. If the performance of this baseline model is not okay, it means that we need to collect more data in the training set. In other site, if the performance of the baseline model is okay, we could use more powerful model like YOLO in our case, or another one, efficiency debt, for example. And after that, we can even optimize the performance of these more sophisticated models by hyper-tuning. The data enrichment is driven by the confusion matrix on your right. It's a qualitative way to know what type of waste images we need to collect more, and so to try to avoid biases. With this methodology, we obtain better results. Normally, it's the end of the project. The client decides to test how artificial intelligence outsize. It chooses 50 objects of waste randomly. And the success was not there. because it imposes a success rate at 80%. Unfortunately, the artificial intelligence identified only 65% of selected objects. Damn, it's a fail. How to explain that? In fact, the statistical distribution of the training dataset is completely different of the dataset used during the final test. The artificial intelligence had no chance, it could only fail. Look, the distribution of on the first graph. It's the distribution for the training datasets. Look, the second graph, especially the pie. And you see, the distribution is completely different. At this point, do we have to give up? No way. This failure is due to the lack of variability of the database. So let's build a more mature database with a real learning artificial intelligence. For this purpose, we develop a specific application called Waste Sweeper, like a waste tender. You see the concept? Look, this application. So you see, it's like Tinder. If the artificial intelligence detects the good label, you can swipe, on the left. If not, you can not, you don't need to validate. You can also validate. Another functionality, you can take a photo. Once the image is taken, you can choose the best label. This application is based on a complete automatization of model deployment after re-entrainment and allows to monitorize the artificial intelligence performance. The idea is to launch this application into 2 communities of early adopters to collect more and more data and hope to get more diversified data. Linked to this application, the client can follow the artificial intelligence performance and can decide when it is satisfied to launch officially the public application. This project is completely in the resilience concept for 2 reasons. This project, of course, has sustainable objectives and practices. Objective, of course, but it's always the management, and practice, but no ghost work. Everything is done by local resources. And also the second parameter, the app design is based on a continuous improvement component for a robust and mature artificial intelligence. Anyway, we have some trouble during this project. And in conclusion, we have some lessons learned for this project. First, don't underestimate the data preparation step, all the data collection, cleansing, formatting, labelization. It's not magic. Sometimes your client think the artificial intelligence can do everything, even go to the moon. You need to explain clearly the opportunities, but also the limits to your client. I will anticipate during the design phase, the monitoring of artificial intelligence performance. And of course, a crucial element, artificial intelligence is still within a research paradigm. So don't expect to understand everything. So my presentation is over from my side. If you have some question, I will of course be there to answer them.
Thank you, Leila. In fact, you were talking about do not underestimate the work on the data. So can you give some sort of an estimation of the work that goes to the data or on the modeling?
So this data step is really a crucial and important work and artificial intelligence project. You know the sentence, garbage in, garbage out. So the data is really important. And probably in terms, if I realize some statistics on that, I will say 80% of all the work has been focused on the data collection and the data labelization, data cleaning, and 20% of the rest of the project will be focused on the modelization.
Okay. So you were talking about first POCs, proof of concepts, and then go into industrialization, so launch it on the market. Are you working on other projects apart from what you have been discussing here or presenting here that are already in a mature stage?
Yes, we work on, for the moment in the pipeline, we work on two other projects. One is already in production, in production. It's a chatbot, an intelligent chatbot. And a second one is it's the beginning of a project in dynamic pricing.
Mm-hmm. Okay, all right. So in your vision, which sectors are the most probable to use artificial intelligence the most? So where do you see the biggest opportunities or the biggest increase of demand?
So from my side, I will say two things. The first thing probably will be the L squares. Because of COVID-19, of course, artificial intelligence will be an important step in the process to modernize all the process in L square, but also to be a support in analyzing data and and also for the different delivering of the drugs. Check look the problems of epidemiology. We are every day we watch the different data and different statistics from the epidemiologist and different models to forecast the status of the epidemiologic phase of our country, and probably the models will be more robust by using artificial intelligence. Mm-hmm. And also the second thing, I will say it's also different techniques of natural language processing to reduce the bureaucracy. Mm-hmm. In different sectors.
Yeah. So to a certain extent, so you would say reducing bureaucracy. Some people are a bit afraid that AI is a job killer. What is your vision about that?
Well, but in a certain way, it will be the case. It will destroy some repetitive task in different type of jobs. But in another way, it's also to free people from very repetitive and painful tasks to create more value and to elevate people and knowledge. So for me it's a good opportunity to embrace artificial intelligence.
It's a leverage. Yeah.
Okay.
All right, that's a very nice conclusion, very positive, optimistic conclusion to this session. I don't see any other questions coming in, so thank you a lot for doing this presentation. And to all the people that are participating, of course, they are welcome at the virtual stand of NRB. Through the platform of Info Security, you can always get in touch with us, ask for a meeting, or ask for setting up a meeting on the platform, or later on, of course, for a face-to-face meeting. If, let's say, the circumstances allow that, we'll certainly organize them. So thanks a lot to everybody for participating this session, and I hope to see you soon on our next presentation tomorrow on info security. Thanks. Bye-bye.
Bye.